Alright, this is the review that I said would be on Moodle of Chapter 3. If you get on here, you just copy in the answers. This is this set of notes you can use on the test. Choose correct word to complete each sentence. If a parallel line cuts, if two parallel lines cut by transversal, then alternate exterior angles are congruent. If two parallel lines are cut by transversal, then corresponding angles are congruent. If parallel lines are cut by transversal, then consecutive interior angles are, this is the one that's different. Remember, consecutive interior are different. They're supplementary. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Name four pairs of vertical angles. So here we want to go through and just do each of these. Vertical angles, the pairs are 1 and 3. So angle 1, angle 3, angle 2, angle 4. Remember, vertical angles are always congruent. Angles 8 and 6. And the last pair, angle 7 and angle 5. Those are all vertical angles. Name all angles that form a linear pair with angle 7. Remember, a linear pair, ones that make a line. So angle 8 forms a linear pair with angle 7. Angle 6 forms a linear pair with angle 7. So they add up to be 180. Name all angles that are congruent to angle 1. Be angle 3 because they're vertical. Angle 1 and angle 6 are alternate exterior angles. And then 1 and 8 are corresponding angles, and that's all of them. Name all angles that are congruent to angle 4. Angle 4 is congruent to angle 2 because they're vertical. Angle 4 and angle 7 are alternate exterior angles. And angle 4 and angle 5 are corresponding angles, so they have to be congruent. Name all angles that are supplementary to angle 3. Angle 4 is because together they make a line. Angle 2 is because together they make a line. Angle 3 and 5 are consecutive interior, so they have to be supplementary. And then angle 3 and 7 aren't anything to each other, but they are supplementary to each other because 5 and 7 are the same. Name all angles that are supplementary to angle 2. Angle 1 is. Angle 3 is. Remember, supplementary means add up to 180. Angle 8 because they're consecutive interior angles. And then also angle 6. The measure of angle 6 is 52 degrees. Find the rest of these angles, so we're up here. Measure of angle 6 is 52, and I'm just going to write them in up here, and you can fill them in down here after you get done. It's 52 degrees. Well, then angle 8's got to be 52. Angle 3 is also 52. Angle 1's 52. To find angle 7, we subtract from 180. That'd be 128. So angle 7 is 128. Angle 5 is 128. Angle 2, alternate interior angles, so they have to be 120. It has to be 128. Angle 4's got to be 128. So that's all the angles. Choose a word or phrase that best completes each sentence. If two coplanar lines are cut by a transversal so that corresponding angles are congruent, then the lines have to be parallel. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. For a line and a point not on the line, there exists blank line through that point that is parallel to that given line. Exactly one. Remember, if we draw this, if there's a line and some point over here that's not on that line. There's only one line in the world that goes through that point that's parallel to the original line. If two coplanar lines are cut by transversal so that consecutive interior angles are, remember that's the one that doesn't fit everything else, it's not congruent, it's supplementary. Consecutive interior, supplementary. If two coplanar lines are cut by transversal so that alternate interior angles are congruent, then the lines are parallel. Which of the following conditions verify that P is parallel to Q? So line P is right here, line Q is right here. Angle 6 is congruent to angle 12. Angle 6, angle 12, since they go opposite corners like this, they are nothing to each other, so that's not one of them. Letter B, 2 is congruent to 4. 2 and 4, if we just look at just the top part, 2 and 4 congruent, they're actually corresponding angles. Sorry, they're actually corresponding angles, but we're covering up line Q when we're trying to prove P is parallel to Q, so that doesn't help us. So that doesn't help. 8 and 16, angle 8 and angle 16 are corresponding angles, and if we cover up this over here, then that does help us because they're corresponding angles, so that one works. 11 and 13, they're vertical angles, they're always congruent, so that doesn't help. Angle 6 and angle 7 are supplementary. 6 and 7, again, those would go with angle R and angle T, not angle P and angle Q. So we'd be covering up angle, or line, not angle R and angle T, line R and line T, line P and line Q. So we'd be covering up line Q, and those wouldn't help us to prove that P and Q are parallel. Angle 1 and angle 15, those are, if we cover up R, those are alternate exterior angles, and if they're congruent, then we know that the two lines P and Q are parallel, so that one would work. 7 and 10, again, we'd be covering up line R. They're consecutive interior angles, and they're telling us that they're supplementary. Well, that's what has to happen for those lines to be parallel, so P is parallel to Q. And 4 and 16, again, they're way on opposite corners. That doesn't, you can't do anything with that, so those are the ones. All three of those, any of those three would help us prove that line P is parallel to Q. Which expressions can be used to represent the slope of a line? Assume that no denominator is 0. We didn't talk about this one, but this is one. This is called a delta. It's called change in y over change in x. That's the slope. Horizontal run over vertical rise. That one's wrong because it's rise over run. Subtract the y's on top, subtract the x's on bottom. That works. This one would work, but it says change in x on top, so that's wrong. Subtract the y's on top. Look at the x's though, they switched them around, so that one won't work. Here, they're both switched around, so that one would work. Here again, they got the x's on top. That won't work. Here they got one y and one x. That won't work. Match the description of a line from the first column with the description of the slope of the second column. A horizontal line. Hopefully you remember that a horizontal line always has a slope of 0. And remember, for a horizontal line, the equation is going to just be y equals some number. A line that rises from the left to the right, so it rises, so it goes up from the left to the right, so it look like that. That's going to have a positive slope. So that's going to be right there. A vertical line slope is no slope or undefined. And a line that falls from the right to, and also on the vertical line, always remember that the equation is always going to be x equals some number, no y's. A line that falls from the left to the right, that means it's going to go down like that. That's going to have a negative slope. Find the slope of each line. A line parallel to a line will slope 3/4. Well, the slope of the new line, if they're parallel, is going to be the same thing, so it's just 3/4. A line perpendicular to the x-axis. Well, if it's perpendicular to the x-axis, which is horizontal, that means the line has to be vertical. And if the line is vertical, then the slope is undefined, or it doesn't have a slope. A line perpendicular to a line with slope 5. Remember, if the slope is 5, then that means 5/1 is the same thing. And if they're perpendicular, then the slope is the opposite reciprocal. So you flip the top and the bottom, and since it was positive, make it a negative. So it'd be -1/5. A line parallel to the x-axis. Well, the x-axis is horizontal, and if they're parallel, then the slopes have to be the same. And the slope of any horizontal line is 0. The y-axis. So the slope of the y-axis is undefined. Identify what each formula represents. This is the point slope formula. Of a linear equation, so of a line. This is the actual slope formula. Don't get that confused with the others. That's just to find the slope of a line. And this is the slope intercept form of a linear equation. Write the point slope form of the equation of each line. The line has a slope of that, and a point that falls onto that. Remember, point slope form looks like this. It's right above here. And all you're going to do is you plug in for the y sub 1, the m, and the x sub 1. This is our y, this is our x, this is our m. So we plug in, we get y minus 5 equals -1/2, parentheses, x minus a -2, so that's actually going to end up being +2. And that's our equation. Next one, we do the same thing. They just turned it around on us. Doesn't matter. This is our y. This is our x. This is our m. We put it in. That's going to be minus a -6.5, so plus 6.5 equals 0.5 for m. X minus a -4.5, so plus 4.5. That's our equation. Which one of the following correctly describes the y-intercept of a line? Y-coordinate of the point where it intersects the x-axis? No. The x-coordinate? No. No. The y-coordinate of the point where it crosses the y-axis? Let's see. Wherever the line crosses the y-axis, that point right there. Find the slope and y-intercept of each line. If it's in this form, remember, that's y equals mx plus b, so in this case, m is 2, the y-intercept is -7. That's the b right there. The next one, what we got to do is move the x to the other side, so we subtract x on both sides, and you end up with y equals -x plus 8.5. Well, the m, that's out front here, is -1, and the b is just 8.5. Next one, we move the x over to the other side. So I'm going to come out here and do this real quick. And we end up with -y equals -2.4x plus 4.8. but we can't have the y being negative, so all we do is change the sign of everything, and we end up with y equals 2.4x minus 4.8, and then the slope is 2.4, the b is negative 4.8. This one, we move the 7 to the other side, so we just add 7 to both sides, and you end up with y equals x plus 19. The coefficient out in front of the x, which is the slope, is 1. The b ends up being 19. This one's in point slope form. You got to do 2 steps. You got to distribute and then move the 5 over. We distribute. We get negative 2x minus 12. We subtract 5 on both sides, and you end up with y equals negative 2x minus 17. Well, the slope is negative 2. The b is negative 17. Be able to switch them from one form to the other, and I didn't have any standard forms there, but you should be able to do that also. Fill in the blank with the word or phrase that completes a sentence. Distance from a line to a point not on the line is the length of a segment perpendicular to that line. Two coplanar lines are parallel if they are everywhere the same distance from each other. In a plane, if two lines are both equidistant from a third line, then the two lines are parallel to each other. The distance between two parallel lines measured along a perpendicular to the two lines is always the same. To measure the distance between two parallel lines, to measure the distance between two parallel lines, measure the distance between one of the lines and any point on the perpendicular to the other line. And the last one, on each figure, draw the segment that represents the distance between the distance indicated. All you want to do here, remember, you don't want to draw something like that. You want it to come over to it and form right angles. And that's all of them.